Hi to all. So in this lecture, I would like to cover the calculation of the net present value of a stream of cash flows, or in other words, the net present value of a project. So net present value is one of the tools that is used by companies to determine if a project is feasible or not feasible, or in other words, is it actually profitable? So when we are evaluating streams of cash flows and value, we just look at the cash flows, not meaning to be redundant. So what matters is how much cash flow are you actually creating from an activity that you are undertaking as a firm. The more or the higher the cash flow that you're able to raise, the better the project. And there are different ways to evaluate whether the initial investment of a project is actually worth the cash flows that such project is going to generate for the company. Net present value is just comparing the initial investment of a firm's project with the cash flows that it is going to generate because of its operations or activities. So let's look at two simple exercises, and we're going to compare basically project 1, project 2. So let's assume, since these numbers are kind of large, and these are distributed in different years in a timeline, and the initial investment is different, just by looking at these two projects, it would be difficult for us to determine which of the two is more convenient for a firm. Now, let's just adopt some assumptions first. So the first assumption is that because we are discussing about the same firm, which we're going to name Capital Corporation. And because we're dealing with the same company, our discount rate will be the same for both projects. So that implies that these two projects are taking place in similar contexts or similar scenarios. Okay? For example, we would need to consider different discount rates if one project was taking place in the US and another project was taking place internationally abroad, and let's say in an emerging economy. So these discount rates would be different, and there are other settings, of course, in which they would be different. But in this case, the settings for these two projects just entail the same discount rate, and both projects will have the same life or the same number of years. Then the initial investments are going to be different. So we have been dealing with time value of money and the present value of cash flows. So this should be actually straightforward. This is just implementing what we have already learned. So how do we implement net present value, and how do we take a decision in this case? Let's just solve this exercise, and let's find out which of these two projects is more convenient for Capital Corporation. So we start with project 1. Project 1, we have an initial investment of $6 million. Now, the first way to address any kind of exercise is just to plot, firstly, start by plotting a timeline. So we're going to plot this timeline. And when we plot a timeline, we're able to visually see what the problem is about. And it makes things easier. So we're just going to have an investment of $6 million here. Following to that, we're going to have 4 years in which that project, let's say this is a machinery, this is a manufacturing plant, this is something like that. So we would have 4 cash flows. So this is cash flow 1, cash flow 2, 3, and 4. Okay? So that is basically the timeline for our project. Now, the $6 million are taking place in year 0, year 1, year 2, 3, let me fix that 3, and year 4. So these $6 million are going to remain being $6 million because they are already occurring today, so we don't need to calculate the present value. So basically the NPV, we will just add these, and then we're going to discount, or in other words, to calculate the present value for each of these 4 cash flows. So we have the first cash flow, which is $3,225,000. 997, and we're going to bring to present value. We are already familiar on how to do that. We know that our discount rate is 13.8, so this is done simply by a to the power of 1. Then we move to the second year. So in the second year, we have a cash flow of 1,775,882. And so we will do the same, 138, but now it's to the power of 2. So let's keep in mind these are the n's. And then we have third cash flow, fourth cash flow. So third cash flow, 1,375, 112, and we are going to divide by 138 to the power of 3. And because I don't want to get into the area that I will need later on, let's continue below. So we're having the fourth cash flow, which is 1,176,558 divided by 1.138 to the power of 4. So what is our NPV? It is just going to be the 6 million. And then we're going to add 2,834. If you do this calculation, it's 2,834,795. This is this. Okay, and then the second cash flow is going to be 1,371,291 plus, and then we will have this, which is 933,064, and let's do the same. Let's go below here, and we're going to have this, which is going to be equal to 701,527. Okay, so I beg your pardon with the numbers below here, and then finally, let's do it like this. Our NPV for project 1, it's going to be minus 159,323, and we're done. So it's quite simple. We have already solved the net present value for the first project that Capital Corporation is evaluating. So now we need to move to the second project, and we're just going to do the exact same thing. Now we are going to plot the timeline, and once more, I encourage you always to plot this timeline so you can approach the problem in a visual way. So the initial investment in this case is 8.9 million, and then we will have 4 cash flows. I'm not going to write all of them, so I'm just going to use these names, cash flow 1, 2, 3, 4. And now the NPV, and I'm going to separate this thing here. So the NPV is simply, again, going to be, we first add the 8.9 million, and then we continue with cash flow 1, which is 2,112,589. So when we solve, let's write this. So it's 2,112,589. So we're going to divide this. Now, what is the discount rate? It could be the case that we had a different discount rate for project 2 than for project 1, but we will use the exact same discount rate in both projects. Now, this is not always the case, but we're going to assume it. So it's just 1.1381. And then we have the second cash flow, which is 3,787,552 divided by 1.138, power of 2. And then I think I have enough space here to just 3,125,650, and we divide this 1.138 to the power of 3. Finally, we have the fourth cash flow, which is 4,115,899, and we divide this by 1.138 to the power of 4. There we go. It's quite straightforward. And now we just I'm going to substitute these numbers for the actual outcome of these divisions. So it's going to be first the 8.9 million, and then we're having 1,856,405, and then we will have 2 million, which is, this is 2,924,651. And then we're going to add the third cash flow, which is 2,120,000 and 868. So if you cannot see this clearly, I'm just mentioning the number. And finally, fourth cash flow, 2,454,119. So finally, the NPV of the second project is going to be 456,053. Now, if we had two projects with a longer life, it may be quite challenging not to solve, but to do each calculation in each period of time. This is time consuming, and this is kind of tedious to solve problems in this way. So let's solve these problems again using the calculator, and that way you will be able to see that it is much easier. So the first thing is we cannot use these white keys, and I'm using the BA2 Plus calculator, because these white keys refer, we can use them more if we had some kind of annuity here, or in other words, the payments were constant. But in this case, every cash flow, these are uneven cash flows, so every cash flow is different. So in this case, we just need to use this CF app. So you first press the CF key, then you press second and the CE button right in the very bottom of the calculator to the left, which is also clear work. And then we start plugging all of the cash flows. The first cash flow we need to plug is CF0. So CF0 in project 1 is 6 million. So we're going to plug 6 million and then negative and then enter. If you don't press the enter key, then this is not going to be saved in the memory. Then we scroll down. We're going to have C01, which is cash flow 1, which is 3,225,997, and then enter. We scroll down. Frequency. If this cash flow occurred more than one time, we could just indicate how many times it repeats in F01. But since we're just observing one time, we're observing this cash flow just one time, F01 is just 1. Then we scroll down, C02, then we plug 1775882, and we press enter. Then F02, again the frequency is just 1. Then we scroll down to cash flow C03, which is 1375112, enter. And we scroll down, F03, the frequency or the number of times this repeats itself is just 1. So this is 1 again. And then we scroll down to C04, which is the fourth cash flow, and we just press 1176558, enter. And then once we have plugged all of the values of the cash flows, we just press compute, and then we press NPV. We can just press NPV. Then it's just going to ask us for the discount rate, which is I. And I, or the discount rate, in both of these cases is 13.8. Now remember, here we're plugging these values as a decimal. In the calculator, we're plugging them as an integer. So we just press 1, we press 3.8, not 0.138, just 13.8, and then enter. And then we scroll down, and we are going to read NPV, and it still shows 0, because we need to press compute. At this point, we press compute, and we just reach the very same solution that we already had in this way, solving it just by calculating one by one the present values. So what is the intuition behind these two? I'm not going to solve project 2 with the calculator, as it would be time consuming, and we would just reach this exactly this solution. So whether you do it with the calculator or you do it using the formulas, you're going to reach the exact same solution. Now, what is the intuition of using NPV as a method of deciding which of two projects is more convenient for a firm? So basically, you're just plotting all of the cash flows that a particular investment is going to generate, but you are acknowledging that all of these cash flows need to be discounted, so you can just use, instead of their value at each of these years, you can use the present value of it. So you bring the cash flow at year 1, which is this 3 million. You bring it back, or you discount it at this discount rate, so you can get the value of that investment or of that cash flow in year number 1. Once you have brought all of these cash flows to present value, then you add all of the cash flows. So you have the initial investment, 6 million, as a negative number, and then you have all of the other discounted cash flows as positive numbers. Now, if these positive numbers are lower or smaller than the initial investment, as in this case of project 1, then you're attaining a negative net present value. Negative net present value would just imply that this project is not creating value, but is rather destroying value. Because, in other words, you're investing more than the value of the cash flows you're going to receive. So you're investing 6 million in some kind of manufacturing plant or other kind of equipment, but that equipment or plant is not generating enough to recover the initial investment and attain some kind of profit. So whenever you see that NPV is negative, then that means that this project is destroying value, and then this project is not feasible or is not profitable for the company. Whenever, as in the case of a second project, these cash flows, after we discount them to present value, we add them, and we add them with the initial investment, and then we attain a positive number, then it means that this is creating value. Or in other words, even after discounting or when discounting all of these cash flows, the overall sum are higher than the initial investment required. So you are investing 8.9 million, but you are generating an even larger value in present value. So then this makes sense, whereas the case of project 1 doesn't make sense. Now, let's do one more calculation, which is going to be internal rate of return. So how do we calculate the internal rate of return? We already have all the cash flows for project 1. So what we're going to do is just calculate here, well, instead of just pressing NPV after we plug all of the values, we're just going to press IRR. Now, it's going to show IRR, and it's going to show 0. At this point, we just press compute, and we are getting the IRR. So we are getting the IRR, which in the case of project 1 is equal to 12.22%. Okay. Now, what is the issue that we have when we find this IRR? Our discount rate, or in other words, our required rate of return is 13.8, whereas our IRR is 12.21. Therefore, our internal rate of return, or IRR, is lower than the required rate of return, or in other words, the discount rate. So in this particular case, this number, whenever it is smaller than the discount rate or the required rate of return, then we should dismiss the project, because in other words, we're not attaining enough to just comply with what we are being required from our investors, or the discount rate, in other words. Now, if we do this exact same thing and we plug all the values here, and we calculate the internal rate of return. So let's quickly do it. So cash flow 0 is going to be, and I'm going to do it quickly. So cash flow 0, the investment is going to be 8,900,000 in negative. Enter. And then cash flow 1, which is 2,112,589. Enter. Frequency 1, cash flow 2, which is 3,787,552. Enter. Then cash flow 3, 3,125,650. Enter. Then the frequency is just 1. Cash flow 4, which is 4,115,899. Enter. Frequency is 1. And then we just press IRR and we press compute. So in this case, we are attaining at an IRR which is 16.06%. So this IRR is greater than our required rate of return. So this project is feasible, or in other words, it is convenient for the firm to move forward with this project. It is not convenient to do so with this project. So this is another method, and you may want to check another video where we learn how to calculate the internal rate of return and the foundations behind it, so you can be clear. Not in all cases, net present value and internal rate of return are going to agree. So you may find some cases in which internal rate of return will be suggesting that a project is feasible, whereas NPV is not suggesting so, or vice versa. So just in this video related to internal rate of return, we're going to see why is this happening and how to just get to or achieve a decision in such cases, and in which both of these methods disagree. So I hope this is quite clear now and that you're able to solve these exercises. I would like to thank you for your attention, and let's keep in touch.